Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithm series. This video is part 2 for topological sorting. In part 1 we had implemented a map of adjacency list from the incoming array of pairs. Now if you want to look into part 1, then I will be sharing the link in the description. You can take a look over there. So once we have this map of adjacency list, we will be using it to create our topological sorting. So how this topological sorting is going to work is we will have three components to it. First will be the element of map, second is the sort array, and third is the temporary array that will be holding the intermediate value. So at first iteration we will read the first element of the array, element of the map. This is map.head, and in second we are going to read the second element of the map. So first element is 0, second element is 1, and sequence of 3. So now how it works, since 1 and 2, which are value for the first key 0, which doesn't have any which has the outgoing nodes. So 1 is a key that exists, 2 is a key that exists, and they have the value as 3. So it means 1 and 2 has the outgoing nodes. So they will be added to a temp array. Now we will go to the next key, that is 1. So in 1, sequence of 3 is there as a value. So 3 also has an outgoing value of 4 or 5. So again 3 will be appended here. So now as we see, as we go further, the values will be appended in our sort and temp. Now in third attempt, again the value is going to be, this is key is going to change to 2 and the sequence of 3. So now as again the value 3 has an outgoing node, so it will be appended to 3, but as it already exists in the temp, it will be there. 2 also exists, so there is no change. Now when it goes to the next key, that is map of 3 and sequence of 4 and 5. In this case 4 and 5 has no outgoing elements, so it will be marked here as sorted. So this is going to be the end node 4 and 5 and their key 3. So from here it's going to enter into the graph. Now at this point, once we have the nodes that doesn't have any outgoing values, so now we are going to append the temp in the reverse order. So next step would be sort plus temp dot reverse. So the output that we are going to see is it's going to be 4, 5, 3, 2, 1, 0. This is how it is going to be. So now let's implement the topological sorting. So for topological sorting, we will require two sub helping methods. One will be to append these to sequence, and another is to add a value to a sequence whenever is needed, and it should also avoid the duplication. So first method is that this method will be add sequence to sequence, and second method is going to be add value to sequence. Now to implement this, def add sequence to sequence, first element is going to be, so there will be two sequence that we need to add. So it will be sequence 2, that is going to be sequence of int, and there will be sequence from, that again is going to be a sequence of int, and it is going to return a sequence of int again. So how this is going to work, so what it will do is sequence from dot fold left. So it is going to start from sequence of 2 and then the method. So method would be sequence of 2 comma each element of the sequence from, and it will check what it is going to check. If st contains t, then it's going to be st, else st plus t. So this is going to return our value as a sequence. This is the first method. Second helper method is going to be add to sequence. This is just going to add a value to sequence. So there is going to be a sequence of int, and there is going to be a value that is type int, and this is going to return a sequence of int. This method is pretty simple, as we saw above. If sequence contains value, then it is going to be sequence, else sequence plus value. So now we have two methods. Next is we are going to implement topological sort. We write a method def topological sorting, which will have the first element as the adjacency map. So let's use the same name what we have here. It is going to be adjacency map, and it's going to be map of int comma sequence of int. Now second element of this method is going to be a sort, which is again going to be sequence of int. Initially these values are going to be empty, so it's going to be sequence of int, and we pass it an empty value, and we have a temp list that is again a sequence of int. This is used to hold the temporary integer values. Now it is going to return our sorted array. So this is how it is going to be. Now we write the method. So we are using a tail recursive method, and we will be comparing the map and adjacency list and the temporary array. So it's going to be first case. First case is we are going to check if our map is empty. If x dot is empty, then we are going to return our sorted list. If not, then what we can expect is we have a value called map, and we call it m, and we have a table, a temporary array. So first thing is we need the head of the map. So map head is equal to m dot head. Now we have the head. Now we need the key and values. Key is equal to map head dot underscore 1, and we need the value is equal to map head dot underscore 2. Now first thing is check if there is any outgoing node. Okay, so how we are going to do, we create a value check degree that will be value dot map, and it is going to m dot get, and here we are going to do the underscore and is empty. This will give me an array of boolean. So what it will do is it will check. In first case we have a value of 1 comma 2 here as the, so this is going to be, first value is going to be 0 and second value is going to be 1 comma 2. So 1 comma 2 both has an outgoing node, so this is going to be false false. Once we reach to 4 and 5, it will become true true. So we have to wait for that. Now we will be creating the temporary list and temporary sorted array that we need. It is going to be So we have to traverse this value, fold left. Okay, it is value, not values, value dot fold left, and we are going to pass this sequence of int empty value, sequence of int empty value, and here we are going to do the operation that we need. So what we are going to do is we are considering all list and we have a value, and now what we want is we do a pattern match again. So it's going to be tmp comma srt, which will be equal to all list. Now we will do a pattern match on tmp comma srt. So this pattern match is to check if srt is empty, then we will do something. If not, then we will do something else. So now first case is tp comma st. So now temporary array and sorted array, what we are going to check? So we are going to check if m dot get what we have bl dot is defined, means if there is some value. So what we are going to see, if there is no value, and not st dot contains the value. So if, like I said, if there is no outgoing node and our sorted array doesn't contain this, so it will return this tp comma st plus vl. Okay, now another case, again tp comma st. If not tp dot contains vl, then it is going to return tp. So this value is going to be appended to temp. So this is how temp will be created at each iteration. So now what is happening is, if there is outgoing node and this value doesn't exist here, so it will be added to temporary. If there is no outgoing node and the value doesn't exist in sort, so this will be appending to sort. This condition is to avoid any duplication. That's it. So now once we have our temporary values here, so next thing is we have to work on this temporary list and temporary sort. So now once we have this, let's see if it is where it is. Okay, so now what we are going to do is, next step is we will be working on whatever we have received as temporary sort 1. We will create another temporary sort 1, temporary sort 1 comma temporary 1, which we will create out of, if you remember, we had this check boolean flag. So we also have to check whether all the values are none or not. So this is check degree. So first condition, we just need to check flag if f contains false. If f contains false, then we need to return tmp sort comma, because sort will be if it contains, then we can't have anything, I mean the key where we need to add. So this basic logic is to append the key. Till now we have added the values here, now we are trying to append. So let's mark a comment here, add the values to temp or sort. Here this is for add the values to add the key to temp or sort. Now as the value is because the flag is contains false, so it means either one of the value has outgoing degree, so it cannot go to So the key cannot go to the sorted array because any of the values has the outgoing degree. So now it will become temp sort. So we have it here as temp sort. Now we are going to add to sequence. Now which sequence we are going to add to sequence is temp and the key. So we are going to add the key here to the sequence. Now another case. Now the next case is my sorted array is nil. What to do now? My sorted array is nil. So sorted array is going to be nil, and we will be doing same thing, add to sequence and temp and the key. Now third case where I have a temporary sorted array. I hope I am not using this. Okay, this name is there, tp srt comma tp lst. Okay, so tp srt comma tp lst comma, I am not considering now anything about the flag because already we have checked that. So now what will happen is I will be adding to sequence. Now we have a sorted value, so now we will be using tpsrt plus k. So first thing is we are going to append our key. Second value is going to be tp lst, and then it is going to pass a nil because now we are overwriting everything that we had in our temp to temp sort 1 and sort 2. Now next thing is this is going to be tail recursive. To every time we need to append the map, every time we have to update the map, and we have to pass the new sorted and temp arrays. So what we are going to do is new sort tmp. So add to sequence. So what we are going to do, every time we get this, we are going to append this. So we can mark it as new sort rather. Okay, new sort. Yes. Okay, add sequence to sequence. Sorry, add sequence to sequence. Okay, now we are using val new temp. It is going to be add sequence to sequence. Here we are going to add the tmp1 because that is what we created, and second one is going to be tmp list. Now this is we have till now achieved. We have created the new sort and new temp. Now m dot filter not, we have to remove the key every time. Okay, now we have eliminated the key. Now new sort and now new temp. That's it. And we have to write the name topological sorting. That's it. Now we are going to test it whether it is giving us, sorry, println topological sorting adjacent map of adjacency list. Hope so that what we have implemented till now runs perfectly fine. Fingers crossed. Yes, now we see the order. Okay, so 0 is coming first. Something we have missed. Okay, we haven't reversed this. Yeah, so because we are going to append in the reverse order, because this is already sorted from the hierarchy. Now it is going to give us, yes, now it is working perfectly fine. So you can try with changing the input to multiple values. Say if I reverse order to this. And I comment this out and I do a reverse. So now everything is reverse. Still I will be getting the same output. You see, now the difference that we see, we had 4 5 and we have 5 4. The reason is if it is reversed, the 5 will, this entire thing will be flipped. So because we are taking a left to right approach, so this is why we are seeing this difference. So I hope this tutorial was helpful. Keep looking for my new videos. Thank you.